Now, looking at this problem, if you were to solve this out, what final answers should raise a red flag that might tell you, hey, you did this problem wrong? A negative or a decimal. Why would either of those numbers raise a red flag? You can't have negative cars, or you can't have a fraction of a car. So make sure you don't get so caught up in the math that you get your answer and then you just move on. Make sure your answer makes sense within the context of that problem. And on these kind of problems in the past, I've gotten on similar problems that there's -2 cars or something like that that just does not make sense. Okay, or if it's talking about something that is, tangible like that, make sure that you're getting positive numbers. So going to 5. AJ, will you read that one?
You have 14 coins in nickels and dimes. If your coins total $1, how many of each do you have?
Okay. So, again, we're going to do the number of. So, Jonah, what is the total number of coins that are in this problem? 14. And let's go ahead and define the variables. Make sure that you try to remember to do that first. So nickels and dimes. So my number of equation is going to be equal to 14. Jonah, what's going to be on the left side of that equation?
X plus Y equals 14.
X plus Y equals 14. Just adding up all the coins. So next, the value. What is the value of a nickel? 0.05. Okay, now don't write this equation out yet. Kind of follow me up here because I'll change it. So the value of a nickel, 0.05. What's the value of a dime? 0.1. And then the value of all my coins together was $1. Now, you can do these equations like this, and that's fine. But by a raise of hand, how many people think that this problem looks like it's easier to deal with? Raise your hand if you think, okay. So, and it's the same thing, it's just don't think in terms of what's the value of a nickel out of a dollar. Think, how many pennies is a nickel worth? 5. How many pennies is a dime worth? 10. How many pennies is a dollar worth? 100. Okay, so you can set it up like that instead. Now, and you're going to see that kind of problem a lot where it talks about coins and setting it up like this. Okay. Now, you won't always be able to avoid using decimals. For example, on the paper I'm going to hand you here in a minute, it talks about the interest of a savings account or bank account or something. Sometimes you can't avoid those. On these kind of problems where it's talking about coins and just the total number of coins and the value of them, you can set it up like this instead, and I think it makes the math a little bit easier. So looking at that, Ryan, which variable would you solve for? Michael? In the first or second equation? What would I have to do to solve for x? Okay. So I'm going to change that equation like that. Next, I want you to take 14 minus y, plug it in for x there, figure out how many dimes and nickels this person has. Should have gotten that y was 6. X was 14. Or sorry, x was 8. On problems like this is why it's important to identify those variables, because whenever you get to the end, now you've got x equals and y equals, and if you hadn't identified your variables, you've got to kind of go back and investigate on which one you used, what variable you used for what. And so the best way to make sure that you do it correctly, again, is to identify them and then write your answers out like this. Okay, don't just have x equals this, y equals this. Write out what they actually are. Okay. Questions on substitution? Turn over, let's look at elimination. For elimination, you're going to set up the two systems, one on top of each other. And I like to think of these as just how you did math problems back in elementary, where you set them one on top, or that's how I was taught. I don't know if they still do it that way. But just one right on top of each other. You're doing the same thing with the equations. But you need to think of them, use those problems and kind of put them in columns. So you've got your x's matched up, you've got your y's matched up, and you've got the numbers of the equation matched up. So using elimination, one of those variables are going to eliminate themselves, hence the name of the process. A lot of times it will just naturally happen with the way the problem's given. So for example, on this one, hopefully you can see that the y's will cancel. Negative 6y plus 6y is going to give you 0y. But if a variable does not cancel, you will have to multiply one or both equations so that one will eliminate. Okay. So like I said on this one, the y's will cancel. And then you would just go down 5x plus 3x is 8x. Negative 32 minus 48 is negative 80. X would equal negative 10. I would then plug negative 10 into either one of the equations. It does not matter which one. And solve for the other variable. Any questions on this process? Yes, ma'am.
What did you get negative 10?
Divided negative 80 by 8. And that gives me negative 10. If there are any other questions on the process there. If not, I want you to go down and I want you to attempt number 1 and number 3. We will talk about number 2. First problem, you should have gotten 5, negative 6. So on this, you should have gotten that R was 2 and N was negative 3. So on 2, there's neither variable cancels out or eliminates itself just the way it is right now. So we need to change either one or both equations by using multiplication. So, Cade, would you cancel out the A or the B?
The A, no, B.
B. What would I need to do in order to cancel out the B?
You add 3B,
Mm-hmm.
subtract 6.
Use multiplication.
Oh.
So if the first equation, if that's 6B, I need the second equation to have negative 6B. So negative 3 times what would give me negative 6?
Negative 3 times 2.
So 2. So I'm going to multiply the second equation by 2. Now I'm going to rewrite my first equation just so that I can have them one on top of the other. It makes the math a little bit easier. Now the B's will cancel, so I have 11A equals 88. So A would be 8. And then I would need to plug that back in to either equation. Solve for B. If you got a decimal, do not freak out.
Oh, it's fine.
It's either 7/3 or 2.333.
That's fine.
Yes. Down to the first word problem. McKenna Wallace, will you read that for us, please?
Suppose your cost receipt $1,084 for selling 205 packages of greeting cards and gift wrap. Gift wrap costs $4 and cards cost $10. Use a system to find the number of each type of package.
Okay, so we will use G as the gift card. Gift wrap. And C as the card. And so looking at this will have the number of and the value equations. So Neil, what would the number of equation look like?
You would do G plus C
Okay.
equals 205.
Awesome. After that, I would make my value of. Okay, so Elijah, what is the value of the gift wrap and the gift card? And how much total did they make on it? Awesome. So looking at that equation, or the system of equations, Ethan, which variable would you solve for? Or sorry, which variable would you cancel? The G's or the C's? Okay. So if this is 10C, I need this to be what? Okay. So what would I do to the first equation? Multiply it by -2. So I'm going to do that and just write that underneath the other equation. So I would get -6G equals -966. So you should get that there was 161 gift wrap packages sold and 44 gift card packages sold. Questions on that problem? Awesome. Going to 5, Miss Kurth, will you read that problem for us?
Yes. Bought 4 crates of lettuce and 3 crates of cabbage. Later he bought 2 crates of lettuce and 5 crates of cabbage. His first bill was $34.20 and the second bill was $31.80. Find the cost of each crate of lettuce and each crate of cabbage.
Make sure you have the variables written out as to what they are. L will be lettuce, C will be cabbage. So this is an example of one that will not have the number of and the value. Now, but I do think these equations are actually a little bit easier to piece together than the other one. First time he went, he bought 4 crates of lettuce, 3 crates of cabbage, and he paid $34.20. So there's your equation right there. 4 crates of lettuce plus 3 crates of cabbage, and he paid $34.20. Second time he went, 2 crates of lettuce, 5 crates of cabbage, and he paid $31.80. So there's your second equation. So looking at the 4 variables, or the 2 different variables, Emily, which variable would you try to eliminate, the L or the C? Okay, so if I do the L, if this is 4L, I need this to be -4L, so what do I need to multiply the second equation by? -2. So I'm going to have, again, I'm going to rewrite the first equation just so that I can have them one on top of each other. So my L's cancel. I end up with negative 7C equals, let's see, negative 29.4. And that tells me that every crate of cabbage came out to $4.20. And then I would need to plug that in for C in either equation. It does not matter which. To find the value of the other. So the lettuce came out to $5.40. And the cabbage, again, was $4.20. Any questions on that one?